All right, so what we're saying is that at the end of the reaction, we might still have some reactants left. And so we want to measure for a reaction, how much product do we have relative to how much reactant do we have? And so this is where the equilibrium constant comes in. And it gets a capital K. And then there's also the reaction quotient. And it gets a capital Q. So both of these are a measure of the ratio of products to reactants. When we talk about K, K is specifically at equilibrium, kind of the end point of our reaction. Note that this K is not the same K as the rate constant. So kind of how in math you use X all the time, in this upcoming chapter and later on, we'll be using K a lot, but there's different Ks for different things. Some of them are interrelated, some of them are not. So while K refers to the reaction at equilibrium, Q refers to a reaction not at equilibrium. So remember here we can plot concentration. And one of our concentrations is going to go down, but eventually level off. And then the concentration of the products is going to increase, but then eventually level off. And at some point at this leveling off, we say that equilibrium is established. So when we're talking about Q, we're talking about the ratio of products to reactants before equilibrium is established. And then when we're talking about K, we're talking about the ratio of products to reactants after equilibrium is established or at equilibrium. And again, this down here is time. And so Q and K are both the products taken to the power of their coefficients divided by the concentration of the reactants to their coefficients. And it's the concentration of the products. So it's always products to some powers over reactants to some powers. It's always products over reactants. So we'll see some examples here shortly.